Hello everyone. Hope your learning is going good. Today I am ready with another presentation on a very hot topic which is the need of the hour, that is IIoT, Industrial Internet of Things. I will be covering this topic in two parts, part 1 and part 2. In part 1, I will be covering the wireless HART fundamentals, and in the part 2, as I have already commissioned and installed this IoT project in my manufacturing unit, so I will be discussing the detailed architecture, what architecture we have opted, and what are the commissioning problems and their solution in the part 2. As the USP of my videos are that you will see all the standards, international standards, which are being covered, which is being followed for creating any new technology. So the wireless HART technology is based on IEC 62591-1. So let's start. So before that, IoT is the industrial Internet of Things. So the bigger figure is IoT. It's not related with the industry. It's for other industries also, that is Internet of Things. So basically, uh, Internet of Things network architecture would have the following four layers. This is the infrastructure layer, this is the service discovery, service management layer, application layer, and business layer. So if I compare with the model which we all know, that is OSI model, then that is physical layer, data link layer, network layer, and transport layer, all the same. But after the four layer, 5, 6, and 7 are here as depicted as business layer, application layer, and service discovery layer. So we will be discussing all the layers one by one. So before going deep into the layers, I want to compare all the networking models with the OSI models. So as we know that OSI model is this one, and we are very familiar with the TCP/IP, that is Ethernet protocol, and in that data link and physical layer is network access layer, and network layer is the IP thing, IPv6 or v4. Transport layer is TCP, and session layer is application layer. In case of HART, that is very important. In case of HART, if we are using a wired HART technology, then the physical layer will be analog or digital signal 4 to 20 milliamp, and in case of wireless HART technology, that will be the physical layer will be IEEE 802.15.4, that is on 2.4 gigahertz frequency band. And about that, data link in the wireless is divided in again two subsystem. TDMA, channel hopping system, is being followed. After that, network layer is redundant path mesh network is being followed. This is missing in the HART technology. And transport layer is auto segmented transfer of large data sets, reliable stream transport, and command oriented predefined data types and application procedure is the session layer. So you can see top two layers. These two layers are common for wired and wireless technology, and in parallel with the wireless HART technology, which is very much dedicated for wireless HART technology thing, there is a ISA 100.11a. This is the International Society of Association. This is being followed in mainly USA, and wireless HART and ISA 100.11a more or less are similar, and very minute differences there. The only difference is wireless HART technology is internationally accepted, and the ISA standard is only accepted in USA. So if you want to skip coming three floor slides, you can skip, because what I have covered in next 3-4 slide is these infrastructure layer detailing, physical layer and networking layer in one point, network and adaptation layer in another point, transportation layer, service layer, application layer, and business layer. All these detailing are covered in the next few slides. Like first one is the physical and network access layer. So you can read it for the knowledge purpose, but you can see that I have highlighted with green that WirelessHART ISA 11.100.11a and IEEE 802.15.4e. These are the some standard protocols defined for the physical and network access layers. And what is the purpose of these two layers? In physical layer, the individual bits are encoded and arranged in data link frames, and the encoded data arranged in a protocol defined frame is pushed to the wired or wireless communication link. Whatever will the if the network is wired, then that frame will be delivered via wire. Otherwise it will be proceed with without wire in wireless data communication link. So this is the basically use of physical and data link. Now comes the network or adaptation layer. This layer is responsible for addressing of data packets over internet. So I have highlighted 6LoW PAN is another network layer protocol for lower power wireless personal area networks. Why I have highlighted it? Because WirelessHART is using this network adaptation layer. Other network adaptation layer are IPv4, IPv6, 6 LoWPAN, 6 load, and other things. Likewise, you can read it, right? So in transport layer, transport or routing layer, we can see that TCP, UDP, TLS, RRPL. These are some popular protocols specified for the transport layer. So this layer is responsible for routing the data packets. Coming to the service discovery or service management layer, this layer basically differentiate the IoT networks or cloud networks with the typical internet networks. And some popular protocol service discovery on IoT systems are these ones. Fine. We can see that application layer. This is the highest layer within the communication network. It is the interface between IoT device and the network. And some of the application layers protocols are these ones. We can refer it: HTTP and JavaScript IoT. HTTP, you can call some any server on direct web link, that is HTTP web link of the server. So that is actually the application layer. And coming to the business, this layer actually is not a part of communication network. It lies with the IoT endpoint. Why I am discussing all these layers? Because when in the next presentation I will be discussing the detailed architecture of IoT, in where you can see that we have opted the Purdue model, that is in line with ISA 199. So in that there are 5 layers are there. So all these 5 layers will be covered there also. So for the knowledge purpose, you can refer it or you can skip it. Okay, as I told, WirelessHART versus ISA 100.11a, that is two standards using both these two standards are using the IEEE 802.15.4 radio technology. And the WirelessHART is the international standard and the US standard is ISA 1. WirelessHART is based on the HART communication protocol and user layer, whereas WirelessHART is a wireless mesh network communication protocol. And WirelessHART protocol number is 7.0, and that is being released in 2007. So wireless design criteria included integrated security, high availability, centralized network management, support for upward and downward interoperability also, with previous and future release of the HART protocol. So if we are going to have HART 7, HART 8 or HART 9 in the future, the HART 7 will be compatible and interoperable. So this is the feature of HART 7 WirelessHART technology. Whereas ISA 100.11a was developed through the International Society of Automation. ISA is a US-based non-profit organization made up of the 20,000 automation professionals. You can read other information also. Yeah. Coming to the network architecture, you can see here that these are the field instruments, wireless HART based field instruments. Along with that, this is the gateway, and there must be network manager or security manager. If I come, yeah, if I wait just a minute. Yeah, if I come to this slide, you can see that these are the layers, and apart from that, these security protocols and managed protocols are compulsory in the IoT system. So why I am highlighting this, because when I am talking about that slide, I will come to that slide. Yeah, this is the slide. So you can see that there is one network manager and there is one security manager. The network manager is your server, from where all the gateways from where all the gateways are communicating, and security manager is used for securing that network. So this is the thing. Okay, and all these things may or may not be connected to your process controller. As in my organization, we have not used this network to our control network. It is going to the host application on the web. Fine. Wireless hard field devices connected to the process or to a equipment. Wireless hard gateways enable communication between host application and VFDs. Support one or more access point. A gateway and its access point must include in every hard network. Next, network architecture. I'm talking about this network manager responsible for configuration of network, scheduling, and scheduling communication between wireless hard devices, management of the routing tables, monitoring and reporting the health of wireless hard network. This is the main use of network manager actually. Coming the earlier when I have discussed about the layer things, that is for commonly layers in this networking model. So coming to wireless HART networking, the physical layer is maximum data rate is 250 kbps. Operating frequency will be 2.4, that is in line with IEEE 802.1.15.4e, and transmit power is 10 decibel. Data link layer has long and short address. Additional wireless HART TLPDU specify a byte which identifies wireless HART packet types. And transport layer provides unacknowledged and end-to-end acknowledgement of communications. And network layer, upstream and downstream graph routings is there, provide redundant path routing for maximum reliability and management latency, support broadcast, multicast, and unicast transmission. So these are the layer specification in case of wireless HART. Conclusion: wireless HART provide new capabilities for users to get information on process parameters. The hard communication foundation provides worldwide support for application of HART technology. That is why it is being used and being adopted internationally. So I will be going a little bit more detail in the physical layer in wireless HART IEEE 808.15.4e. These things are just for knowledge purpose, as the objective of creating these videos or these sessions are only that you will get all the information in single video. You need not to refer any other video or any other presentation for any other information. You may skip the information or slides according to your need. So physical layer in wireless IEEE, the intention of the amendment is to enhance and add functionality to the 802.15.4.206 MAC to better support of the industry markets, explicitly call out HART and SP100 elsewhere. So specifically, the earlier physical layers like TDMA, channel hopping, GTS, CSMA, security, and low latency are some features which are being not that much accurate or reliable in other protocols, in other physical layer. So that's why IEEE 802.15.4e is being introduced in wireless HART. So you can see that this is the 2.4 gigahertz frequency band, and the radio transceiver are omnidirectional, half duplex, 100-meter with 0 decibel. Time to switch between channel 0.192 millisecond. Radio turn on time second is 4 milliseconds. So the transport layer in wireless HART is based on time synchronization MESC protocol. This is common for ISA SP100 that is being discussed, and wireless HART both. Okay, the application of WirelessHART is the same application is being used here also. The monitoring of vibration, temperature, and acoustic sensor. These three transmitters, these three sensors are being installed here in my organization, and over a wireless HART technology, and we are using all that for monitoring and healthiness checking purpose. So another use may be parking monitoring. We are right now commissioning this project, and to how many persons are there in the plant in that particular of time, we can track with the wireless devices. So this can be useful for parking monitoring also. So I will be discussing in part 2 how we are going to implement this. So some basic question: why wireless? Cost reduction is there, easier installation, easier maintenance, and flexibility of sensor replacement. And challenges in wireless are also there: strict timing requirement, reliable communication despite wireless deficiency, plant environment are inherently unreliable, high security concern. The plant environment are inherently unreliable, so that's why we are not going to use it in tripping or controlling purpose. We are using it in open circuit only. So wireless technology, earlier we have a star network, so that is being used in Zigbee or Bluetooth, in which one particular element can be connected with multiple devices. But you can see in mesh network, any equipment can be connected with nearby one or two devices. So wireless HART for process measurement and control application is rarely being used. So feature of industrial IoT is reliable 99.9%, secure self-organization, organizing facilities there, self-healing is there, interoperable, support both star and mesh topology, built in time synchronization also. So this is the another architecture where we can see some wireless devices. This is the network manager, process manager, and this is the gateway which is communicating with the network manager. So network manager, again, centralized brain. What does this network manager do? Centralized brain manages the network and its devices, collect topology information, routing and scheduling. It does generates network management packets to devices, changes when devices link and breaks. User administrator interacts with the network manager. If you want to log in into the server, that is being done through the network manager only. So these are the some photographs, field devices photographs. Like you can see, this is the heart. Just wait. Yeah, this is the heart Rosemount 648 wireless heart temperature transmitter, and Rosemount 702 wireless heart transmitter. We are using this 648 in our system, and you can see this is the antenna which enables the communication with a non-native device through a wireless heart network. Okay, and what is the purpose of using gateways? Gateway is one or more host interface connecting the gateway to backbone network, one or more access point providing the physical connection to the wireless network. In a single gateway, we can connect multiple devices so that network manager can easily read all the required information. So gateway can support up to 80 devices. This may vary from company to company. What we are using gateway, in that we can use 100 number of devices at a time. So in wireless HART technology, how to achieve reliability? These are the some parameter that is I will say these are some technologies being used in the wireless HART technology that make this technology super reliable. That is time diversity, channel hopping and channel blacklisting is there, route diversity, graph routing, and power diversity. These some diversification is being used in this communication, which make this communication safe. So what is time slotted channel hopping? Earlier, yeah, we checked that channel hopping is one of the channel diversity application. So this is already being this is the part of IEEE 802.15.4e, and switch channel for every time slot to enhance reliability. This is the main objective of time slotted channel hopping. So we can see there are two types of shared and dedicated time slots. So in the wireless HART technology, we are using shared time slot. So shared time slot means multiple sender attempts to sender to a receiver, and the first data which is being received by any device is being further transmitted to server through gateway. So this is the shared time slots. Another point is channel hopping is being used, which also enhance the reliability by avoiding interference and reduce multiple path fading effects. So and routing is there. Wireless HART support both graph and source routing. So we can see in the picture, this is the source routing, and this is the sensor, and this is the server. So 1 to 2 and 3 4, like this data will proceed, and if the graph routing is there, then the data may go to in this direction and may to this direction, so that the data should not be lost in any case. Scheduling, the transmission is followed by a retransmission on the same link on a dedicated slot, then again on another link on a shared slot. So all the slots, dedicated and shared slot, is being used for transmission of any data. Super frame is one of the funda which is being used for wireless HART technology. This is the super frame, and in which you can see A to B, B to C, C to D, and some rest time is there, and another some rest time is there. So this is the super frame is being transmitted through a wireless network. So in this single super frame, you can see A to B, B to C, and C to D. Three datas are being transferred. Okay, so you can say same you can see same type of cycle is being formed in super frame. Multiple devices can communicate with the multiple another devices. So this is the super frame technology. And network initialization, after commissioning of any devices and router and project. So network initialization is required in a network automatically starts up and self-organize. Before a network can form, a network manager and a gateway must exist. The network manager activates the first super frame. This establishes the system epoch. ANSI is 0. Once the network access point starts to advertise, device can begin to join the network. So this is the first step we need to do while taking into the line all the devices. And if I can share you some network maintenance procedures, a keep alive must be transmitted to the neighbor if last time communicated, or keep alive interval. Keep alive transmission are repeated until a new DLPDU is received from the neighbor. Keep alive no more often than once per 30 seconds if temperature varies 2 degree per second. Path failure are reported to a path failure are reported to the network manager while device lost connectivity to neighbor. After the path fail interval lapses, path down alarm is being generated. So this may vary. These alarms and further action may vary from time to time, from server to server. So these are some network maintenance in my server actually. So best practices is each field devices should have at least 3 neighbors. Device antenna mounted is greater than 0.5 meter from any vertical surface. Device mounted should be 1.5 meter off the ground, and 25% of the network device should have a direct connection to the gateway in the large network. So this is all about the fundamentals of the wireless HART technology. You may listen to this video one or two times to be more clear about this technology, and I will be coming with part 2 where I have installed in my organization this wireless HART technology. Till then, goodbye, and I request you to like and subscribe my channel to get a video notification as soon as I upload in the channel. Thank you.